Okay, now we have the second part to what we were working on here. You see that I have the original function. In the last example, I showed that how we could create our inverse. So this was f inverse of x. That's what I have listed over here. And the direction said, find the solution set for when the original function is equal to its inverse. And so I set this up here. Again, when we look at this, our goal is to get a polynomial. So we could put this into the polynomial root finder and actually find our answers. And so what I did was I took the cubed root part, the most complicated part, the part that was giving me issues in the equation, and I set it equal to e, just some arbitrary letter. And what I'm going to do next is get it so I can solve for x. And so just from this little statement here, I'm going to cube both sides. That gets rid of the cubed root on this side. And then I move the 2 over. So e cubed plus 2 is equal to x. That allows me to come back through here and plug that stuff in so I can start to get to a polynomial. And so I'm going to write 3 minus x is now going to be replaced with e cubed plus 2. So I write e cubed plus 2 minus 2 raised to the 1/3 equaling 3 minus e cubed plus 2 raised to the 3rd plus 2. On the left-hand side, you can see that the 2's will cancel out, and so we would have 3 minus e cubed to the 1/3. Well, e cubed to the 1/3 is just going to be e. And then on this side, this is going to be 3 minus e cubed minus 2. So negative e cubed is going to be there, but 3 minus 2 would become 1. And so I could list this as 1 minus e cubed cubed plus 2. Now if you want, we can go ahead and take this 2 over here. I didn't do that in the last example, but if you want to get rid of it, you can get rid of it and call this 1 minus e is equal to, and then this would be 1 minus e cubed raised to the 3rd. I'm going to expand this using the properties of expanding cubics. So I would say 1 minus e is equal to this cubed, a cubed, first term cubed, would be 1. Now the next part would be 3 times 1 squared times b, which is negative e cubed. And so that would become minus 3e cubed. Then we would say plus 3. A would be 1. B would be negative e cubed squared. So that would become plus 3. Now this squared would become positive e to the 6th. And the last term would be a negative times a negative times a negative. It would be negative e cubed cubed. Negative times negative times negative is minus e to the 9th. And so I'm going to move all those terms over, and I'll just have a polynomial. And I can call this e to the 9th minus 3e to the 6th plus 3e cubed minus e, because it's already over here, minus e. And if that 1 comes over, that would drop out because this would be 1, take away a 1, that drops out. This would equal 0. And so just like that previous example, my first step here is to pull an e out. And then I would have e to the 8th minus 3e to the 5th plus 3e squared minus 1 equals 0. Case 1, easy to do. E would equal 0. And the second part, well, I'm going to have to put that in a calculator using that polynomial root finder. So I hit apps, go to polysmult2. Now the number could be any number, it depends how many apps you have, but you're looking for polysmult2, polynomial root finder and simultaneous equation solver, version 2. And so I go down to that, I call that up, and I'm looking to find roots, to find zeros. So polynomial root finder, it's still set at 8 from the last problem I did, so I can just go to next. And now I have to plug these coefficients in here. The first coefficient is 1. The fifth coefficient is -3. The second coefficient, which would be x squared, would be 3, and -1. Now I can tell it to solve. You say, Mr. Criswell, that was the same as the other problem. Yes, it was, but there's going to be a slight difference. We're letting us solve here. I'll explain what that difference is. I still have those imaginary roots. I still have the 1. I have the 1.54. That was the same answers that I had before, except for now when I write this, I'll say E equals 1, E equals 1.154, E equals 0.682, E equals -0.536. Okay, here's the difference. I know you wait long enough for me to tell you what the difference is. When these get plugged in, they're now getting plugged into this expression. And so when I look at this, I would plug 0 in there. 0 cubed plus 2 would equal x. So now I get a 2 for one of my answers. When I plug the 1 in there, it would be 1 cubed plus 2 equals x. Hopefully you're following what I'm saying. I'm plugging them in here where I had it solved for x. So when I plug the 1 in, 1 cubed plus 2 gives me 1 plus 2, which is 3. So now I get 3 equals x for an answer. And then I can do the same thing with these other ones. I'm not going to waste time going through that. This is easy mathematics now. You just cube that, add 2, that's your x. Take the 0.682, cube it, add 2, that's your x. You can plug those right in the calculator. And then -0.536 cubed plus 2 equals your x. And that gives you all those solutions then. And so you'll have 1, 2, 3, 4, 5 solutions. Again, list those out from least to greatest. The objective for these problems was that you become comfortable with this substitution. It's kind of a new idea. It's a powerful idea. In this case, when we did our substitution, we were actually able to work with our statement and rearrange it so we had an x here by itself. And then once we had our solutions, we were able to come back. It's really just a substitution. And I like the power that it had there because you were able to do a substitution and it utilized that calculator. It said, let's use that calculator, let's use the polynomial root finder for a reason. And we didn't have to graph it or anything like that.